Hey guys, welcome back to another A-Level Maths Made Easy video. This topic is the modulus function, and we're going to cover quite a bit. In fact, everything to do with the modulus function. In my opinion, this is one of the worst taught, and also the topic that has the most misconceptions in it. So I think the beginning part will start off quite nice. So if you haven't done it before, it'll be a really good intro. If you have done it before, you might want to skip a bit further ahead. But this topic here requires that you sketch functions all of the bloody time, especially when you're solving equations. So again, there's a lot of misconceptions with this, so I'm going to hopefully address all of them, and that way you have a much better understanding of what the modulus function is and why it works. I'll have another video on some of the really hard modulus questions that can come up probably a bit later on, but for now let's start with the actual beginning. So as usual, most of the people that watch these videos are not subscribed, so if you do find any of this useful, please consider just subscribing. It really helps me out. If you look at the link in the description, there is my website where I have tuition and all sorts of other things there, and my email address in case you want to ask me any questions. So of course the first question we should ask is, what the hell is the modulus function? Well, the modulus function is represented by these two vertical vertical lines here, and essentially all they do is they make the value inside those straight lines positive. So if you go to your calculator, the button is actually called abs on your calculator because it means absolute. And if I put in a negative value, let's say -3, I will get +3 out. If I put in just normal +3, it stays as 3. So it doesn't flip the sign or anything like that. It literally just makes the value positive. And again, it doesn't really matter how big the number is, it will just make it positive. So first things first, we need to basically just sub in values. So f of 6, when the function has abs like this, has the modulus part of it, it will be 6 minus 4, which means it's 2, which means the value is just equal to 2. And the same for b, it would be the modulus of 3 minus 4. Then you would just make that the modulus of -1, which of course is just 1. So this is really useful when we don't consider the negative values. So when we deal with things like speed, distance, and not acceleration, but speed and distance, and lots of other values in real life, we usually only care about the positive values. We don't care about negatives. But as you sub in for all of these, as you can see, anytime it's a negative, it just becomes positive. And the same thing happens over here. So with the last three questions, we have G. And what will happen here is the value subbed in will become positive first. Then you're going to work it out. So the answer can be negative. The only thing that matters is that the value that you sub in initially becomes positive. So again, anything inside this modulus signs become positive, and that's all you get. So hopefully you can find that's nice and simple. So let's see where this goes a bit later on. The next thing that's really useful is when you have to sketch graphs. So sketch each of the following graphs showing the coordinates of any points of intersection with the axes. So for example, if I just draw the regular y equals x plus 4 graph, here is what I would get. So I'm going to draw this in blue. We'll get a line that goes through here, y equals x plus 4, which means the y-intercept is 4, and this value over here is when y equals 0, which is when, so 0 equals x plus 4, so minus 4 equals x, so that value would be minus 4 over here. So what happens when you put the modulus sign around the expression, the equation? Well, all that happens is anytime this is negative, so this thing inside the bracket is negative, it becomes positive. So let's kind of test this out for a second. Let's say we have x is a number smaller than -4, because as I can see, y is negative when it goes below the x-axis, right? That's when y becomes negative. So let's test it out, right? If we have x equals -5, what's going to happen? Well, we have the modulus of -5 plus 4, which means we get y is equal to the modulus of -1, which means y is equal to 1. So instead of going down constantly, now the value is actually going up, right? Because again, instead of it being -1, -5, it's going to be -5, sorry, Instead of it being -5, -1, instead it's going to be -5 plus 1. So all of the values where y is negative now become positive. So the graph will actually look exactly the same as this, it's just that it almost bounces off the x-axis and becomes positive. Hopefully that makes a little more sense. Okay, so how else does this look? Well, again, if we take the graph of y equals x squared minus 9, once again, if I draw this out, we're going to have an x squared graph will look vaguely similar to that, where these 2 points, well, what are they? Well, remember we would have x squared minus 9 equals 0, so that's x plus 3, x minus 3 equals 0, you have x equals minus 3, x equals plus 3. By the way, this topic is heavily based on being able to sketch a bunch of different functions, even ones that you haven't done before. So you should definitely keep that in mind. And the way that I'm doing this is exactly the way I'll do it in the exam, where I'm drawing the original graph and then using a different color to show what the new graph would look like. And oh yeah, down here would be -9. So once again, all of the values below the x-axis, so when y is negative, will now be positive. So instead of crossing at -9, it's going to actually cross at +9. And once again, instead of going below the x-axis, it's going to like bounce off. And all of these values will be reflected up. So anything below the x-axis now goes like this. And it's going to look something like that. And then it would still go up like this, so it still follow this up. So it's like a big W. And that's what that'll look like. And again, that's because all of the negative values for y become positive, which is really key feature there. Once again, we've got a few more that I want to show you. Y equals the modulus of sine x. Now, it does say between 0 and 2 pi. If you haven't done the radians chapter, this is the same as between 0 and 360 degrees. So once again, if we draw out this graph, and what I'm actually going to do to make it my life a little bit easier is I'm going to move it to the right, because we don't care about negative values of x. And if you remember how the sine graph looks, it goes like this. That's almost perfect, that's really nice. So 0, and then it goes, 90 degrees, it goes between +1 and -1, and then that's 180, that's 270. So every 90 degrees, something interesting happens. So it goes between 0 and 1, 1 and 0, 0 and -1, and -1 and 0. Now again, have a think. In fact, pause the video and see what will happen to this. By the way, if you had this between 0 and 2 pi, so if you had it in radians, it would be pi over 2, pi, 3 pi over 2, and 2 pi. Well, again, all of the negative values for y are reflected upwards. So instead of it going through the x-axis, again, it bounces off the x-axis. So this 270 minus 1 is now going to be up here. It's going to be 270 and plus 1. So it's going to look something like this. And again, it does follow this original curve. And that will be y is equal to the modulus of sine x. So again, my method is you draw the original graph, and then anything below the x-axis you put to the you put above the x-axis, and that's basically the only difference. So now, once again, we have y equals 1 over x. So all of these graphs are graphs that you need to be able to do just on the fly. And if you remember what the y equals 1 over x graph looks like, it looks like this. If you want a video on like how I memorize or how I know or learn how to kind of sketch a bunch of different functions, then do let me know in the comments. And again, anything below the x-axis is now reflected up to the positive. So it'd be like this. And then of course this one stays exactly the same because it's already positive. Remember, the modulus function doesn't affect positive values, it only affects negative values. Lastly, but certainly not least, we're going to do the ln graph. And again, this is just to kind of show you the types of graphs that you're expected to be able to sketch. They can show you, give you pretty much anything. They give you tan, cos, sine, whatever. And normally your ln graph looks like this, where it goes through the position, the point 1 and 0. Now, the only difference here is that this is going to bounce off and come up this way. Because again, anything below the x-axis becomes positive. So I know we've kind of repeated that a hell of a lot, but when else is this useful? Well, it's also useful when you're solving equations. And this is where I find students make mistakes all of the time. They do not sketch graphs out. So here we go. This is what we're going to do. With this equation, here's how schools normally teach it. Is they just say, oh, you make it negative and you make it positive and that's it. Now that is not a good enough reason. Okay, it's not good enough. Instead, let's draw out the graph first. And the reason why I'm going to draw out the graph is to illustrate to you why you can't just arbitrarily make things positive and negative, okay? You can't do it. It's just an idiotic thing to do. And the reason why I say it's idiotic is I really like this topic. I think it's a very good topic. I think that you can gain a lot of marks for doing very little. Sometimes these questions can be worth 2 or 3 marks. It's a linear equation. Now, why am I getting into this? If I draw the graph of x minus 5 quickly, that's what it's going to look like roughly. And if you wanted it equal to 3, all you would do is you would draw a line at y equals 3, and you can clearly see that it only crosses the equation, crosses the graph once. So there's one solution. So there's one solution for x minus 5 equals 3. Cool. I fully agree with that. But look what happens when we actually draw the x minus 5 modulus function. Well, now everything that's below the x-axis now goes above the x-axis. How many times does it cross? It crosses twice. So normally in our linear equation, if we had x minus 5 equals minus 5 equals 3, we have one solution because the graph of x minus 5 crosses y equals 3 once. But now we have the modulus function, there are 2 solutions. Because when we sketch it, it will cross twice. Now, how do you know what the values are? Well, if you notice, this graph here, this blue part of the graph, is just x minus 5. That is the graph of y equals x minus 5. Just this blue part here. So one of my solutions is when x minus 5 equals 3. Because again, the blue part is just the graph of y equals x minus 5. Which means one value is x equals 8. Boom. Now have a think about what the red line, what the equation for that graph is. Well, if you notice, the y-intercept, over here it is minus 5, over here it's plus 5. So this value on the end is going to be something plus 5. Now have a look at the gradient. The gradient should be the same as the blue line, but it's going down instead of up. So it's minus x. That's the other equation that we're solving. So again, the way that some teachers teach it, and I would argue it's not even teaching it, is they say, well, x minus 5 equals 3, and then brackets x minus 5 equals 3, but they put a minus on the outside. This is not always true. And in some cases, it makes it worse. So I've got a couple of questions later on where you can't just do this arbitrarily. You'll get the wrong answer. Instead, I prefer my way where you actually look at the graph and you actually understand what the hell's going on. But that's where your teacher got it from. It's where, again, this is technically true, but only because when you expand it, you get the actual equation of the line. But anyways, if we solve this, we then get minus x equals minus 2, and therefore x is equal to 2. So, hopefully that makes a little more sense. But again, you have to be very careful with where you're dealing with this. Now, if you're wondering why x is not a negative number, it's because on my sketch, the intersection's on the negative side. In actuality, it seems like it should be more steep like this, so it crosses on the right-hand side of the graph. But again, that doesn't really matter. The sketch is mainly there to tell you how many times it intersects. So let's see if we can do this now. So once again, I've given you basically the same type of question. I'd recommend pausing the video and just quickly having a go and seeing what will happen. But for those of you that have remained, again, draw the graph out. Get into this habit, because I guarantee you, in your exam, you may get screwed over. So once again, we're looking at plus 1. and we're looking for the intersection when it equals 15. So, like so. And again, when we actually do this calculation, it's going to intersect quite far away, but there's 2 points of intersection. The first one is when the normal graph, x plus 1 equals 15, so x equals 14. But in the other one, the y-intercept is now somewhere below this line. It's at -1, right? If we continue this red line along, if we wanted to, maybe I'll continue it in green, it would cross at -1. And it's obviously negative x because the gradient is negative. Once again, in this case, you can just put the negative on the outside of the bracket. I'm not saying that you can't do that. I'm saying don't do it without reason. Okay? So that is the way how you find the opposite part of the graph. And you get negative x equals 16. So x is equal to negative 16. And those are the two answers. And again, for 3 marks, it's worth doing the slightly longer method to make sure you're not making a mistake. But let me show you 2 questions now where you cannot just arbitrarily make things negative. So here is exactly where people make mistakes. Because here, if you do it the normal way, well, first of all, you might say x minus 2 equals x plus 4. Okay, but then which one do you make negative? So do you do x minus 2 equals minus x plus 4? Or would it be minus x minus 2 equals x plus 4? Or would it be both of them negative? And the most common question that I get from students is, in the mark scheme, they'll only do 2 of these. Because these graphs will only intersect twice. I'll prove it to you in a second, but they might also only intercept once, by the way. But the most that they'll intercept is twice. At minimum, well actually no, at minimum 0 technically, but they'll intercept once or twice. So here we have 4 different equations, we'll get 4 different x values. And the worst thing is, and this is the really key thing, is for 2 of them, you'll get an answer that's nonsense. So you might get like x equals x or something like that, which means, 0 equals 0. And people start to panic. So if you did this, all 4 of them, you would get the right answer. But you have to be prepared that for at least 2 of them, maybe 3 of them again, you will get an answer like this, which is a null statement, right? You can't derive anything from that because they don't intercept each other. You will not get x equals 0, okay? For me, that's confusing. Well, A, it's twice as much work, right? Sometimes, it might even be 4 times as much work if it only intercepts once. And 2, getting this in your exam would scare the life out of you. So instead of doing this, I'm going to get rid of all this, and we're going to be smart about it. We are going to draw the graphs. So, let's have a look. Again, draw a decently large axis. If we do x minus 2 first, that's going to look like this. Maybe I'll bring it up a little bit just to make it look at... Whoa, careful. Wait. Hello? Just a little bit, just to make it like this. And then, of course, when we actually draw the modulus function, it probably should be a little less steep than that, but that's okay. So that is my graph of y equals x minus 2, and then the graph of y equals mod x minus 2. And then I'm going to use 2 different colours. So I'm going to use black for this one. So we have x plus 4. So that would be, it should actually be a little higher because that's at 2. So something like that. And then let's use green for the rest of it. So if you have a look at this, 2 things I want to say. They intercept once. Right? They intercept right here. Now, here's the question I get given is, and this is a really good point. How do we know that those 2 graphs, if they go off infinitely, don't eventually intercept outside of my sketch? Because I've done it before where when I've drawn the 2 graphs on a single set of axes, I actually get 2 solutions because they actually intercept further outside of the scope of my sketch. And students then say to me, well, how do you know? I can tell by looking. How can I tell? Well, here, I know for a fact they do not intercept again. Why? Because their gradients are the same. They are parallel, which means these 2 lines going off will stay equally distant from each other forever. And the red and green line going off will stay equally distant, like train tracks, forever. So the black and blue, parallel. Red and green, parallel. Because no matter what, they will have the same gradient. The only reason why the black and red one intercept is because the red one has a negative gradient and the black one has a positive gradient. That's the only reason why they intercept. So the only solution to this equation is the red one, where you have minus x minus 2. So you basically have minus x plus 2. And you have the positive black line, where, in fact, I didn't actually write what the black line is. That's honestly a bit sloppy. X plus 4 and y equals mod x plus 4. So that's where you would have equals x plus 4. That is the only solution. So I'm going to add x to both sides. Take away 4 from both sides. So x equals minus 1. That is the only solution to this equation. And again, the reason why I know it's the only one is because those lines are parallel. They will not cross again. If we had something like 2x plus 4 and x minus 2, then they would intercept again somewhere to the left. And that's how you could tell. Okay, so let's try it again using one that's a little different, right? So we have y equals x minus 5 and y equals 7 minus x. And once again, do not do that thing where you just shove negatives in front of all of them. It is stupid. It's just not a good idea. It's a really dumb idea. Let's draw x minus 5 first. It's going to be down here somewhere. Whoops. So y equals x minus 5. So then when it becomes positive, it's going to go quite shallowly. Sure, that's an adverb, right? That's 5 minus 5. And if we draw the black one, that's 7 minus x. So it's a graph that goes down. It crosses at 7, of course, and then back up. And I also know, by the way, that these should have the same gradient, because they should. So y equals 7 minus x, and then the green part is going to go off with the exact same gradient as this one. That's actually a pretty good sketch. I'm actually relatively happy with myself for once. That sounded depressing, but hopefully you get my point. So how many times do they intercept? Well, they have the same gradient. The magnitude of their gradient is the same. It's 1, which means they're parallel, which means it crosses once. So it crosses right here. So that is when we use the black line, 7 minus x, equal to the blue line, x minus 5. Have you noticed what I've done? I didn't even use the whole putting a negative outside, right? Because I've drawn all the graphs. I've drawn all 4 graphs. So you don't even need to do the minus x minus 5 or whatever, because guess what? I've drawn all the graphs. I can just look. I can see, well, the black and the blue cross. Well, black is 7 minus x, blue is x minus 5. How easy is that? Remember, something that I say to a lot of students is keep it simple, right? The simpler you keep it, the less likely you are to make mistakes. So add x to both sides, 2x minus 5. Add 5 to both sides, we get 12. And again, x equals 6. And this does make sense because it's on the positive x-axis. The very last thing is, again, one of the most annoying parts, because what we're going to do is we're going to look at the difference between the mod of f of x being over the whole of the function. So basically making y positive. So make, if you remember your transformations, this might help. And f of mod x, where essentially you're making x positive. And this is a really, really, really key skill. So honestly, with this first one, I'm sure you guys already know what this one will look like. So you have 3x minus 1. So normally that would look like a straight line going down and diagonal. But in this case, it's going to go down, quite steep, and then go up. It should be equally steep, where that is plus 1, and it hits the ground at a third, comma 0. How do you know that? Just make y equal to 0. You get 3x equals 1, x equals 1/3. But how does it look when you have mod f of x? So if I write that out for you, This is the equation that we're basically sketching. Now here is where I'm actually going to draw it separately. Okay? And what I mean by that is I'm going to draw it in the classic way that I did before, where I draw both diagrams on one thing. So if I do 3x minus 1 first, you get something along those lines, right? That's minus 1. That's y equals 3x minus 1. Now, when I make x positive, what does it mean? Well, it means that, and I've thought of so many ways to explain this because it's quite tricky. But essentially, if I look at a plotting table, right? Look at a plotting table. The positive values will be the exact same as the negative. So if we do 0, 1, 2, and 3, 0 would be minus 1, 1 would be 3 minus 1, which is 2, that'd be 6 minus 1, which is 5, and 8. Now, if I sub in a negative value, you would expect the values to get negative, right? So normally, 3 times minus 1 is minus 3, take away 1 is minus 4. So normally you'd expect minus 4, minus 7, minus 10. But we're making the x values positive. So what does that mean? It means that subbing in minus 1 gives the same result as subbing in 1 because we're making the x values positive, which means instead of having that, we have 2, 5, 8. Because again, I put in a negative value, it gets made positive because of the modulus, then the same thing happens again. So think about it. If I put minus 3 in, make it positive, that's 3 times 3 is 9, minus 1 is 8. 3 mod minus 2, well, you take the modulus of minus 2, it becomes 2. 3 times 2 is 6, minus 1 is 5. And so on. So what does that mean? It means our graph can be negative y values. It's allowed to be a negative y value. But all of the x values basically just become a reflection. So the way I like to put it is you mirror along the y-axis. So whatever's on the right of the y-axis, you draw the same thing on the left-hand side. So you draw it like this. Now, that might not seem too impressive right now, but have a look at when we do some of the later ones. So the next one I'm going to do is I'm going to do a quadratic graph for you. And you're going to see why things get a little bit weird. Because again, the right side and the left side become perfect mirrors of each other when you take the modulus of x. And the reason for that is every negative x value gets changed into its positive version. So, let's have a look. Here we have a classic quadratic. However, there's something else going on here. So, if I draw the graph normally, here's what it would look like, x and y. So first of all, we want the y-intercepts. The x-intercepts, which would be x equals minus 1 and x equals 5. So if we label those, boom and boom. But if you expanded this, you would notice it's a minus x squared. So in our case, it's actually going to look like a big sad face. Like so. And where does it cross? Well, if we sub in x equals 0, we get 1 times 5, which is 5. I should actually label those 2 points as well. So, what happens when I take the modulus of this graph? Well, remember, everything below the y-axis becomes positive. So that's going to be like this and like this, which is, fantastic, right? So now you're probably thinking, you're probably stressing a little bit, what the hell does this look like when you have f of mod of x? So for the sake of simplicity, I'm actually just going to draw that all on one graph. So I'm not going to draw 2 graphs. So the right-hand side will stay exactly the same. But remember what I said about the left side. So imagine I've just copied this part of the graph here, moved it over. Honestly, I'm not happy with that drawing. Come on, there we are. That's gone slightly better. Well, it becomes an exact mirror. So I'm going to draw the same thing on the other side, but mirrored around. where that is, well, it's also 5, but it's -5. You know what I mean? It's also 5 there. So it looks like a giant M. I will admit this isn't the best looking drawing. I might even copy over one that I've done on the... So basically I used Mathematica to also plot these. So if I show you, again, hopefully you can see where I'm coming from with this. Yeah, this is speed, this is. Alright. So again, if you look, we have those flicks at the end for either side. And again with this, it comes up like a giant M shape. Now, again, I did this by plotting it on a software. That's why it looks better. Now, there is something I should mention with plotting graphs and things like that, is they don't care about the shape. You're not meant to be Pablo Picasso, okay? We're not Da Vinci over here. All we care about is the general shape. So the fact that it's curved, the fact that it's in the positive Y quadrant will get you the marks. So I would get full marks even though this is absolutely hideous. Why? Because I have the correct coordinates. -5, 5, 5, -5, 5, 5. And because I have the general shape. The idea that it is kind of like a duplicate copy on both sides. But I do admit that it's a little bit sloppy. It is a little bit sloppy, I'll admit that to you. And coming on to the last one, which is fun. Now, let's draw the one on the left. So again, remember this is going to be y equals f of x. Oh, jeez. And you have an asymptote at y equals 0. So you might notice that the y equals f of x graph is actually the same as mod f of x. Because remember, the e to the x graph can never be negative. Because when you put something to a power, it can never be negative, assuming it's a positive base. But have a think about what could happen when we do, and maybe I'll do it on the same set of axes, f of mod x. Well, again, the left and right side will be complete mirrors of each other. So instead, we're going to have something that looks like this. Almost looks like a quadratic. And again, for the sake of me being very... I knew I wouldn't be able to draw it super well, but just to show you guys. So the original function and the mod f of x function is the exact same. And then here again, it kind of just looks like it should be more of a tip, which I think I've got the tip fairly well. But again, remember, we're not Pablo Picasso. All we need to do is make sure that we label those coordinates and we're done. So honestly, here's the main misconceptions. A, with the drawing, it's pretty hard. But B, the biggest misconception I see is with solving the equations. I promise you right now, if you sort this out in your head and you understand how to do this, your life will become a lot easier. I have a ton of extremely hard questions, harder than any exam question ever, that I can go through, so do let me know if you want me to do that. But generally speaking, sketch the graph, see how it overlaps. Because they can also give you quadratics, things like that, and it gets really fun. But again, if you found it useful, please consider subscribing as it really does help me out. But I hope to see you in the next one, and have a great day.